I'm Anil Kumar, and here is question number 15 on combination of functions from previous test papers. The question is, consider the function f of x equals to x squared minus 1 and g of x equals to x plus 1. Determine algebraic model for h of x, which is product of these two functions. Sketch h of x for x between minus 2 and plus 2. Describe the graph of h of x and list 5 characteristics. Okay, so what we can do is, let me write down h of x first. So h of x is product of these two functions, so I'm straight away writing, right? So it is x squared minus 1 times x plus 1. It's good to write it in factored form, so we can write this as x plus 1 times x minus 1, and we have x plus 1. So h of x can be written as x plus 1 whole square times x minus 1. So we get h of x, which is a cubic function, right? Now we can sketch this graph in the interval minus 2 to 2. So we have zeros at, we have a double zero at minus 1. So let me do like this. Let me take 2 units as 1. Okay. So this graph is not very clear. What I'm doing here is I'm using 2 units as 1 along the x-axis. Okay, so what we have here, this is 1, this is 2, like this, minus 1, minus 2. So we have to just sketch between these 2 points. So we have zeros, 2 of them. At minus 1 we have a double zero, so we have a 0 minus 1. Then we have a 0 at 1, so we have a 0 here. So let us find the value of h of 0. That is going to help us. So that is 1 times minus 1, that is minus 1. So at 0 we have a value which is minus 1. So let's call this as minus 1 for us. Okay. Now the end behavior of this is it's a cubic function, correct? Positive leading coefficient. So the graph actually will be kind of, let me just sketch a rough one here, right? So it turns from here, continues and goes like this, right? So that is the kind of graph which we are expecting here, correct? So let's find the value at 2 also and minus 2 also. So at minus 2 the value will be, if I substitute minus 2 here, at minus 2 plus 1, you can use your calculator, right? And then write down the answer. So this is 1 positive, and here we have minus 3, so we get minus 3. So at 2 we have minus 3, so this is 1 for us, and then this is 2 and this is minus 3. Okay, so at 2 we have minus 3, and similarly we can find the value at 2. At 2 we are going to get 2 plus 1 square times 2 minus 1, so that is going to be 9, right? So at 2 we are going to get 9. So 1 2 3 4 5 6, kind of high up, right? That's okay. So we can draw now a graph of this function. Okay, so let me take a different thing. We'll join these points, right? So we have, it has to turn from here, go back kind of like this, and then kind of go like this to, let's say that is the point, correct, at 2, which is 9. So that is the function which represents the product of these two functions. Now you need to write 5 characteristics, right? So what we can write here, 5 characteristics, you could say that since we are given restricted domain, sketch this function, describe the graph of h of x and list 5 of its characteristics. So for the given domain, we can write what is the domain, what is the range, right? So we can say domain is x belongs to real numbers, so that x is between minus 2 to plus 2, and then range we can give as y belongs to real numbers, and the lowest value is minus 3 for us, and the highest value is 9 for us in this particular domain. And we can say that we have 2 zeros, right? 2 zeros or x-intercepts, I should say real zeros. Okay, now it has two turning points. And like this you can define so many parameters, and it has, you can say, so we already have four characteristics here. Okay. And of course it's a cubic function, so we can write cubic function. So that is the nature of polynomial cubic function. Okay, now that is how you can write more characteristics of the function. I hope that helps. Thank you and all the best.